Good afternoon, students. I think you are safe. Your parents, well wishers are safe from COVID. Stay home, be safe. Okay, so welcome to the fifth lecture of Unit 1 R&AC of Mechanical Engineering third year subject. Today in this session, we have some topics related to the refrigeration. In the last class, we have discussed about some of the topics related to the heat engine, heat pump, and refrigeration, the differentiation between the heat pump, heat engine, and refrigeration, and the air refrigeration cycle, and the mechanical refrigeration. Today, in this session, we will discuss about the other topics related to the refrigeration. So, in that, the topics are merits and demerits of air refrigeration cycle and types of refrigeration cycle. Types of refrigeration cycle. So, here the topics to be discussed are one by one. So we'll see the topics. So what we are discussing one by one. So the first one is, what are the merits of air refrigeration system whenever we are using the refrigeration? So what are the demerits of air refrigeration system? So coming to the merits of refrigeration system, first one is the air coming from the refrigeration is easily available and there is no cost of refrigerant. So whenever you are using air refrigeration, so only in the air coolers, air conditioners, we require the refrigerant. So whereas here, the air what you are using, here the air what you are using is very freely available. Second one, the second one is the air is non-toxic in nature and non-inflammable. So what is non-toxic? So we don't have any excess. We don't have any excess smell. We don't have any foul smell, and also non-inflammable. What is the meaning of non-inflammable? So non-inflammable means the air doesn't catch fire, right? The air doesn't catch the fire. That is non-inflammable. Next, what is the third one? The leakage of air in small amounts is tolerable. So whenever you are using the air conditioning, so generally we go for the robust design of fixing the equipment. So that's why we don't require any dangerous sort of setting the refrigerator. So thereby the air leakage is very small and there is no danger when there is a leakage in the air, right? Next one, since the main compressor is employed for the compressed air source, therefore there is no problem of space for extra compressor. So here in the air refrigeration, due to the optimized design, the compressor is already inbuilt in the design. So that's why there is no additional space required for the compressor whenever you are utilizing the refrigeration. Whenever you are utilizing the refrigeration. Next, since the air is light in weight per ton of refrigeration. So if you see air conditioner, so we are having ton. So we are dealing the air conditioners as 1 ton, 1.5 ton, 1.2 ton. So here we don't have the problem of tonnage of refrigeration. So that's why the air is very light in weight per ton of refrigeration. Next, third one. Next one is the chilled air is directly used for cooling, right? So whenever you are using air conditioners, automatically automatically the chilled air is directly we can use for the for our purpose. So what is the main purpose? Cooling of the room, cooling of the objects. So directly we can use for cooling, thereby eliminating the cost of separate evaporator. So we are reducing the space and we are not using the compressor, and also we are eliminating the cost of separator. Additionally, we don't have requirement for purchasing the evaporator. So that is inbuilt process. Since the pressure in the whole system is quite low, pressure is very low, therefore the piping, ducting, etc. are quite simple to design, fabricate and maintain. So what is the other merits we are saying? So the whole system is compacted and optimized design. Therefore, the piping, ducting, etc. are quite simple in construction and fabrication and also in the maintenance. Coming to the demerits of refrigeration, it has low coefficient of performance. So what is the demerits we are having? So it is having very low coefficient of performance. Next, the rate of air circulation is relatively large. So whenever you open the door of a fridge or whenever you open the door of any AC room, automatically the cool air is passing outside. Why? Because the cool air is heavier than the hot air, thereby the rate of air circulation is very large since it is having the coefficient of performance low. So that's why this is a demerit. The air circulation is very large, which is a demerit. Next, 1 second. So you're having some problem in the screen. Okay. Now see the simple air cooling system. So the design of a simple air cooling system. See here. So if you get a question in exam, so you can draw the simple line diagram like this. See here. So what are the main components you require? So the main components of the air cooling system is the gas turbine, main components, main compressor, sub compressor. So just this is a setup. This is a setup where the air is going in and air is coming out, and this is the outside atmosphere. Okay, now this is a gas turbine and this is a main compressor, right? From the ram air, the ambient air is passing into this chamber. Here it is passing into the heat exchanger. So exchange of heat takes place in the heat exchanger chamber. So here the air is passing into this chamber, right? So it is passing to the main compressor and passing into the channels of the heat exchanger, and it is passing into the cooling turbine. From the cooling turbine, the balance air is to the cabin, right? So again, the balance air is passing from this main compressor to the combustion chamber, and it is passing into the gas turbine, and it is passing into the main compressor and flowing in this manner through the heat exchanger. It is passing into the air cabin. So whatever the ambient air from the ram air place, it is passing to the heat exchanger process and it is making this channels cool, and it is coming into this pipe chamber and it is going to the atmosphere through the fan. So this is a simple air cooling system we are using in nowadays applications, right? So what are the main components you are having? Cool air fan, cooling turbine, gas turbine, main compressor, combustion chamber and heat exchanger. So these are the main components of air cooled system process. Next. So if you see the TS diagram for a simple air cooling system, so the x-axis you are having entropy S, the y-axis you are having temperature T. Temperature T. So here, see here from 1 to 2, from 1 to 2, the cycle, again 2 to 3. So here the deviation you are seeing, the deviation is between the temperature change. Again 2 to 3, so you are having the temperature change from 3 to 4. Again the temperature is reduced from 2 to 4. It is reducing towards the temperature 5. So like this you can see the TS diagram for a simple air cooling system. So here you are having the pressure changes here. So the first one is the pressure 1 ambient temperature. cabin temperature, and actual ram pressure, and the ideal ram pressure. So these are the various temperature differences. T5, T6, T1. So T1 దగ్గర T1 temperature, T5 temperature, T5 ambient temperature, T4 is the temperature, and T3 and T3 dash. So why the deviation you are seeing here? So because the change in the temperature, because the change in the temperature 5 shows the change in the temperature 3. So that's why in the simple TS diagram of a simple air cooling system, the diagram is shown in this manner. Next, coming to the air refrigeration system for aircraft cooling. So generally we are using air refrigeration for all applications, roadways, railways, seaways and airways. But in your syllabus, you are having up to the aircraft cooling setup. So if you see the air refrigeration for aircraft cooling system, the applications are external heat gain due to the solar radiations. External heat is gained due to the solar radiation. So we are having a pin called solar radiation. Due to that solar radiation, the heat is gained and we are getting the heat. Next, heat released by the occupants. Heat is released by the occupants. So whatever the people you are having in the airplane or in a railways or other thing, though generally a body have some sort of temperature. So when the body is increasing, the occupants are increasing, automatically the heat is also gained from the body. Internal heat gain due to the external and mechanical equipment used. So what is the other heat gain you are having along with the occupants? Electrical and mechanical equipment systems used. So what are the mechanical instruments like a compressor, condensers, evaporators, and also electrical supply? All these give the additional quantity of air internally. So externally we are having the solar radiations, internally we are having the electrical and mechanical components along with the occupants. Next, types of air refrigeration system. So what are the various types of air refrigeration system? So the first one is simple air refrigeration system, bootstrap air refrigeration system, regenerative air strap refrigeration system, reduced ambient system. So these are the main types of air refrigeration system. So we see these types in detail. Okay. So coming to the simple air refrigeration system, the first one, in a simple system, the compressed air after cooling in a simple air refrigeration system, a compressed air after cooling in the air cooler is passed through the cooling turbine. Obviously, whatever the air is passing into the compressor, it is the compressor get compressed. Later, it is cooled in the air cooler. Later, it's cooled in the air cooler and passing into the cooling chamber. So, what the figure shown in the previous, see here, this cooling chamber. Okay, cooling turbine. Next, the work of this turbine is to drive a fan. So what is the main purpose of getting the air cool into the cooling turbine? So to drive the fan which draws the cooling air through the heat exchanger, see here. So the air is drawn through the heat exchanger process. Third point, the air is discharged from the turbine at the pressure slightly above the cabin pressure, right? So the air what is discharged from the turbine place through the heat exchanger at a pressure slightly above the cabin pressure. Next, the fan is put on the downstream. The fan is put on the downstream side thus avoid the additional temperature rise of the cooling air. Okay, the fan that is put on the downstream side, thus avoid what? Additional temperature rise of the cooling air. This system is good for ground cooling since the fan driven by the turbine is the source of providing the cooling air by the exchanger. So however, the turbine work is not available for the compressor. So the simple air generation system is having a source of providing the cooling air from the heat exchanger only, right? From the heat exchanger only. Next, if you see the line diagram of a simple air refrigeration is same as that of the above figure what I have shown. See here, the simple air cooling system or a simple air refrigeration system, right? So here the ambient air is passing into the chamber. There, there, the air is passing from the main compressor through the gas turbine through the combustion chamber and it is passing into the heat exchanger. There, it is passed to the cool fan to the atmosphere. So this is a simple process of air refrigeration system, right? Okay, next. So the figures, the TS diagram is already shown in the previous slide. So when you get a question about a simple air refrigeration, draw the figure, show this, and show the line diagram of this simple air refrigeration along with the TS diagram. Next, coming to the Bootstrap air refrigeration system. The Bootstrap system has two heat exchangers instead of one. So if you see the Bootstrap, you are having one heat exchanger, other one you are having second heat exchanger. Okay, so whereas in the air refrigeration simple type, you are having one heat exchanger. Here you are having two heat exchangers. Only the thing you are having two exchanges. Remaining everything is same. So see here the ambient air is passing through the ram air and it is passing to the main compressor and the gas turbine, and from this through the compression chamber it is passing into the first heat exchanger, second heat exchanger. It is passing into the first heat exchanger process, right? Later it is taking the air to the secondary compressor and it is going into the secondary heat exchanger. Later it is passing into the cool turbine to the atmosphere, right? So only the thing is you are having first compressor, second compressor, one exchanger, two exchanger, right? So the bootstrap system is having shown two heat exchangers instead of one, and the expansion turbine drives the compressor rather than the fan. Therefore, it cannot be used for the ground cooling. Therefore, it is not be used for ground cooling. The primary purpose of bootstrap system is to provide in an additional cooling capacity when the primary source of air does not have any sufficiently high pressure to provide the amount of cooling required. The turbine drives the secondary compressor is to raise the pressure of primary air before it enters the turbine. It is used for high-speed aircrafts where the velocity of aircraft provides a relatively airflow for the heat exchangers. Therefore, the separate fan is not required. So the bootstrap system is generally used for the high-speed aircraft applications where there is no need of separate heat exchanger. Separate heat exchanger is not required. So that's why if you see the bootstrap air refrigeration system topic, see here you are having two compressors. You are having two compressors and two heat exchangers. Right? You are having two compressors and the two heat exchangers. Next. So if you see the process, if you see the cycle process of heat exchanger, bootstrap heat exchanger, so we are having various steps to be noticed. Various steps to be noticed. So what is the first step here? The process 1, 2. See here the process 1, 2. The process 1, 2 represents the isentropic ramming. The process 1, 2 represents isentropic ramming process. Isentropic ramming process where see here the 1, 2 process 1 to 2 process. So this one ramming process 1 to 2 is a ramming process. So ramming of ambient air from pressure P1 to temperature T1 to the pressure P2 to T2, and a temperature air pressure is passing from 1 to 2. Air pressure is passing from to T. See here the temperature T1, temperature T2. The process 1 to represent actual ramming process because of internal friction due to the irreversibilities. Next, coming to the process 2-3. So what is the 2-3 here? So 1 to 2 and 2-2 3. 2-2. So what does this mean? Isentropic compression of air in the main compressor. The process 2-3 actual compression of air. So what does the 2 2 3 dash and 2 dash 3 dash? What does it say here? 2 3 is a main compressor. 2 3 dash is the main compressor. 2 to 3 is a secondary compressor. Right? 2 to 3 dash 2 to 3 is a main compressor. 2 dash 3 dash actual compression of air because of internal friction due to the irreversibilities. Next, the process 3 dash 4 represents by ram air in the first heat exchanger. The pressure drop in the heat exchanger is neglected. 3 dash 4 here 3 dash 4 3 dash 4 here the change in the temperature from T3 to T4. So you are getting the change in the temperature. The process 4 represents the isentropic compression of cool air from the first heat exchanger to the second compressor. The process 4 5 represents the actual compression process because of internal friction due to the irreversibilities process. The process 5-6 gives a cooling by ram air in the second heat exchanger, and the pressure in the heat exchanger is neglected. So if you see the 5-6 process, next, the process isentropic expansion of cooled air cooling turbine to the cabin pressure. The 6-7 dash represents the actual expansion of the cooled air in the cooling turbine, right? So here it is showing this one. Cool air from here the heat exchanger to the cooling turbine is showing 6 and 7, right? 6 and 7. Process 7 represents the heating of air up to the cabin temperature T8. So this is a temperature entropy diagram of Bootstrap air refrigeration system. So simply just draw the x-axis entropy, y-axis temperature. Here T1, T2, 3, T4, T5, T6, T7. So here you are having negative 0.1, 2, 2 dash, 3 dash, 3, 4, 5, 5 dash, 6, 7, 7 dash. Got it? This is the case in the regenerator type of system. Next. Sorry, next bootstrap system. Next, third one is regenerative air refrigeration system. So the regenerative air refrigeration system has two heat exchangers but does not require ram air for the cooling of the air in the second heat exchanger. So see the difference in the bootstrap and regenerative. So in the regenerative, what did you say? You don't have the separate cabin. So the air is coming from the surrounding air at high velocity and it is passing into the ram air. So from here, through the gas turbine main compressor, It is falling combustion chamber and it is passing into the heat exchanger process, and one is passing into the second heat exchanger and the other one exit the exhaust here. Other one is the regenerative heat exchanger and is going to the cabin. So this is the regenerative type of cooling system. So what do you say here? It has two heat exchangers but does not require RAM air for cooling of the air in the second heat exchanger. Second heat exchanger, so there is no use of rammed air. It is a modification of simple air system with the addition of secondary heat exchanger, in which the air from the primary heat exchanger further cooled with a portion of refrigerated air bled after expansion in the turbine as shown here. It provides the lower turbine discharges temperatures but at the expense of the some weight and complications. So this is a simple line diagram of regenerative type of refrigeration system. Next, if you see the TS diagram of regenerative system, so as already shown in this figure, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, like this. So here if you see, so you are having the changes here. So here it is showing 1 to 2. Here 1 to 2 is the ideal ramming process. 2 dash 3 ideal compression process. 2 dash 3 actual compression. So 1 to 2 is a ramming process, right? So 2 dash 3, 2 dash 3 is actual compression, 2 dash 3 dash is ideal compression. Therefore temperature changes here. And 3 to 4, 3 to 4 is a cooling in regenerative heat exchanger, and 4 to 5 cooling in the regenerative heat exchanger, and 5 to 6 ideal expansion cooling in the heat exchanger. And the changes in the pressure is P1 at P1, P2 and P2 dash and P3. So what that is saying here, P1 is atmospheric pressure, P2 is ideal ram pressure, P3 is actual ram pressure, P6 is a cabin pressure. So this is a general type of regenerative air refrigeration system shown in the TS diagram. So generally this type are used for ground cooling as well as high speed aircraft, whereas the Bootstrap air refrigeration system does not require for the ground cooling system, but the regenerative system is used for ground cooling as well as high speed aircraft systems, right? Next, open air refrigeration system. In an open air refrigeration cycle, the air is directly led to the space to be cooled. Okay, so in an open type, the directly air is passing into the chamber and getting cooled, allowed the circulation through that cooler and then return to the compressor to start the next cycle of the cooling. Since the air is applied to the refrigerator atmospheric pressure, since the air is applied to the refrigerator at atmospheric pressure, air pressure low, atmospheric pressure, therefore the volume of air handled by the compressor and the expander is large. Thus, the size of compressor and expander should be large. What is another disadvantage here? The moisture is more. Moisture is regularly carried away by the air circulated through the cold space. So, in this open type of system, the moisture is carried away by the air circulated through the cooling space. Thus, it leads to the formation of frost at the end of the expansion process and clog the ductal line. Thus, an open system is the dryer should be used. So, in order to reduce the frost and clog, so what is the thing you have to use? The thing we have to use is the dryer process where you are drying the material. Next one, closed or dense air refrigeration system. An open type air is passing into the refrigerator, and also the dryer should be used. Whereas in the closed or dense air refrigeration system, in a closed or dense air refrigeration system, the air is passed through the pipes under ducts at all the time. So in a closed type of system, the medium, the air is passing through all the pipes and ducts and maintained continuously. The air in this system is used for absorbing the heat from the other fluid. So what it is saying here, the air in this system is used for absorbing heat from the other fluid, say brine refrigerator, and this is cooled brine is related to the space of the cooled. The air in the cooled system does not come in contact directly with the space to be cooled. So in this cooling system, the air does not come in direct contact with the space to be cooled. So through the refrigerant called brine, we are cooling the setup, right? Closed air cycle has the following thermodynamic advantages. So what are the advantages here? Since it can be work at the suction pressure higher than that of the atmospheric pressure, the volume of air handled by the compressor and expander is small than that of the refrigeration cycle system. Next, what is the second point here? The operating pressure ratio can be reduced. So the ratio, the operating ratio can be reduced, which gives higher coefficient of performance, right? Whereas in the full type of thing, we are having a disadvantage called low use quotient of performance. Whereas here, whenever the operating pressure ratios are reduced, operating power ratios are reduced, automatically the COP is increased. Okay, next. Next topic is types of ideal cycle refrigeration. Generally, we are having two types of ideals of system. So, what is the first type? The first type is air refrigerator working on reversed Carnot cycle. The first type is a air refrigerator working on reversed Carnot. The second one is air refrigerator working on Bell-Coleman cycle or reversed Brayton cycle or Joule cycle. So these are the ideal cycles of refrigeration system. So these are used depends upon the application and depends upon the climatic condition, right? So we discuss types in detail with the lumps. Okay, now see here. The first one is air refrigeration working on reversed Carnot cycle. In refrigeration systems, the Carnot cycle consider is reversed Carnot cycle. We are using reversed Carnot cycle in the refrigeration system. So when the heat engine working on the Carnot cycle has the highest possible efficiency, therefore a refrigeration system working on the reversed Carnot cycle will have maximum possible coefficient of performance. So whenever you are using the Carnot cycle as a medium for Carnot cycle for the refrigeration system, there is a possibility of highest possible efficiency and have the maximum possible COP. We also know that it's not possible to make energetic engine working on the Carnot cycle. So by using of the Carnot cycle, we can't make use of engine possible. Similarly, it's also not possible to make a refrigerating machine working on the reversed Carnot cycle. So whenever it's not possible of using engine, it is also not possible of making in the refrigeration working on the reversed corner cycle because it is used as a ultimate standard of comparison. So the air refrigeration working on reversed corner cycle is generally used for the commercial applications, and we'll see the concept in detail now. See here, the figure shows so on the PV and TS diagram, what we have mentioned earlier in the refrigeration cycle, we are having a one, let P1, V1, T1 be the pressure, volume, and temperature respectively. We are having 4 processes of cycle to be discussed. So what is the first process? Isentropic compression process. The first process is the isentropic compression. So generally in the first process, automatically the air should be compressed isentropically. So what's happening here? The air is compressed isentropically at the curve 1 2 on PV and TS diagram. At this process, the pressures of the air increases from P1 to P2. So by drawing the figure, you can easily write what's happening in process 1, what's happening in the process 2, like that, right? From P1 to P2, it is increased, and coming to the volume from V1 to V2, it is decreased, and also the temperature also increases from T1 to T2 as a pressure increase అయినప్పుడు temperature increase అవుతుంది, but volume అనేది తగ్గుతుంది. That's happening in the isentropic compression process, where no heat is observed or rejected by the air. So ఇక్కడ ఈ ప్రాసెస్ లో ఎయిర్ అనేది that is the heat is not absorbed or rejected by the air. Coming to the isothermal compression process. So in the second concept, the air which is entered from the first 1-2 cycle, the compressed isothermally, the 2, 3 and previous diagrams are drawn. At this process, the pressure of air increases from P2 to P3, and the volumes are decreased from V2 to V3, but the heat rejected by the air during the isothermal compression per kg of air see here, from the stage 1 P1 to P2 increased, pressure increased, thereby temperatures also increased, the volume is reduced. In the isothermal compression process, the pressure is again increased from P2 to P3, right? But the temperature is constant at a 2-3 level, thereby the volume is decreased from V2 to V3. So the heat is rejected by the air per kg of air. Therefore, the heat is equals to Q23 is equals to area of 2 to 3 and 3 dash to 2. That is, area తీసుకుంటే T3 of S2 minus S1, S2 minus S3 is equals to T2 of S2 minus B. Next, third one is isentropic expansion process. So what are the first 2 cases? Isentropic compression process, then isothermal compression process. ఇక్కడ isentropic expansion process, isothermal expansion process. Only the thing is isentropic, isothermal. So what's happening in the third case? The air is now expanded isentropically on the curve 3-4. On the curve 3-4, on the diagrams PV and the pressure air is decreases from P3 to ఇక్కడ ఏం జరుగుతుంది, ఎక్స్పాన్షన్ జరిగినప్పుడు whenever the expansion process takes place, automatically the pressure is reduced from P3 to P4. ప్రెజర్ తగ్గిపోయినప్పుడు వాల్యూమ్ అనేది ఇంక్రీజ్ అవుతుంది. ఎక్కడ ఫ్రమ్ V3 to V4 the volume is increased and temperature is also decreased from T3 to T4. At this process, no heat is absorbed or rejected by the air. Next, fourth process. So T1 T2 లో ప్రెజర్ అనేది ఇంక్రీజ్ అయ్యింది. ఐసెంట్రోపిక్ ఎక్స్పాన్షన్ ప్రాసెస్ లో P3 నుంచి P4 కి ప్రెజర్ తగ్గింది. సో టెంపరేచర్ ఇస్ ఆల్సో తగ్గింది, బట్ వాల్యూమ్ అనేది పెరిగింది. నెక్స్ట్, isothermal expansion process. So what's happening in this process? So in this process, obviously the air is expanded from P3 to P4. The air is expanded కాబట్టి isothermally at the constant temperature. Here the constant temperature maintain చేయాలి. T4 దగ్గర నుంచి T1 వరకు the pressure of air is increased from P3 to P1, P4 to P1. So ఇక్కడ ఏం జరిగింది? The pressure is decreased with the constant temperature, and also the volume is increased from V4 to P1. Thereby, here the heat is absorbed by the air during the isothermal expansion per kg of air. So third process లో heat అనేది absorb చేయలేదు or rejected. Here the heat is absorbed either isothermal per kg of air in this process. So these are the four things to be drawn whenever you are using the reversed Carnot cycle. So if you see the derivation, Q of A, Q of 4 minus 1. So we'll stop here. Why? Because you are having less than 1 minute. So from tomorrow we'll start the problems by using the formula. So I will say this derivation tomorrow, how it has been come, or simply we can see the area of 4123. So first area తీసుకోండి, T4 of S1 minus S4 is equals to T4 of S2 minus S3 is equals to T1 of S2 minus S1. So therefore the cycle per kg of air WR is equals to heat. WR is equal to heat rejected minus heat absorbed, that is QR minus QA is equals to Q23 minus Q41. That implies T2 of S2 minus S3 minus T1 S2 minus S3 is equals to T2 minus T1 S2 minus S3. Therefore coefficient of performance is equals to heat absorbed by work done.